Here is an explanation for final exam question number 67 on page 528 of Physics Demystified 2nd edition. Page 528 if you have the hard copy edition. Consider three perfect sine waves x, y, and z. Well, here we're only showing x and y. We'll get to z in a minute. Three sine waves x, y, and z. None of them has any DC component, so their positive and negative peak amplitudes are equal. They all have the same frequency, so that we can define relative phase. Wave x leads wave y by 120 degrees. That means wave x occurs earlier in time than wave y does. Now, 120 degrees, here's one complete wave cycle of 360 degrees. Each one of these divisions is a sixth of a cycle. That is the equivalent of 60 degrees of phase, because 60 times 6 equals 360. So 120 degrees of phase is a third of a cycle. Wave x is a third of a cycle ahead of wave y. Okay, now we can talk about wave z. Wave y leads wave z by 1/6 of a cycle. That means wave y occurs 1/6 of a cycle earlier in time than wave z. So z is 1/6 of a cycle later in time. Here's wave z. We can just draw this. It's a little bit tricky. It's a little bit tricky. Wave z follows right along in the same frequency, but 1/6 of a cycle later than wave y. So wave y is 1/6 of a cycle ahead of wave z. We're being asked, how do waves x and z relate? Okay, we can mark a point z right there. 0 and positive going. Wave x, 0 and positive going over here. So they are 180 degrees out of phase. That means that they oppose each other in phase. Remember, these are perfect sine waves, so when they're 180 degrees out of phase, if they're perfect sine waves with no DC components, then they oppose each other in phase. Phase opposition with perfect sine waves of the same frequency is the same thing as being 180 degrees out of phase. So this question we answer with choice E.